Yeah, our agenda are four presentations. I will give an introduction, especially connected to our project that we have in the European Climate Initiative. That's the reason why we are doing this online seminar. And I will give a little bit of overview from our project and some aspects that we are working on. Robert will cover all the positive aspects of cover crops and carbon sequestration, and then we will have two presentations about experiences on farm with two different systems. Monika and Robert run a farm in east of Poland, and they have a very nice system of undersowing serradella into cereals as a cover crop. Then Alois from Austria does lots of different cover crops, that's will be very interesting. So, first, a short introduction about our project. We have a project funded by the Ministry of Environment in Germany and EU, which is quite unusual. Usually, we are funded by Ministry of Agriculture. But this is in the frame of the European Climate Initiative. So agriculture is only one aspect of climate. Of course, most of projects about industry and traffic and transport and these things. So our topic is improving carbon balances on organic farms for the sequestration of atmospheric carbon. So we want to improve organic farms. Organic farms already are quite good usually, but nevertheless we have a potential to improve. And in first phase of this project, we only worked with arable farms, but now we're in second phase from 2025 to 2027. And now we also included horticultural farms and wine and fruit into the project to also cover this this project. So these aspects. So our partners in the project are KISS, the agricultural institute in Slovenia. So Robert is from KISS, the next speaker. So the other partners are the agricultural Institute of Serbia in Novi Sad, and INHORT, the horticultural and fruit institute in Poland. So that's our partners, and that's the consortium. So we're working on best practice examples for improving carbon balances. That's, for example, cover crops. That's why we are here today. Cover crops is a method that are relatively easy to apply. We're doing, of course, a lot of activities in this, but we also work on partly more difficult aspects. We also work on how to integrate clover and clover grass, alfalfa into rotations in organic agriculture. That's more difficult. We're working on grain legumes. Well, that's easier. We want to promote use of compost. There are potentials. We are promoting the use of manure, especially from biogas plants and of biogas plants that use clover and alfalfa for their digestion. And another topic is agroforestry. We already had an online seminar about agroforestry in during this project, and you will find this in the Naturland Academy. So, our most important activity in the project is communication, to spread the results and the knowledge to farmers, politicians, and general public. So we're doing on-farm trials on all these kind of farms. And in Poland, Slovenia, and Serbia. And we're doing field days to show our on-farm trials. We're doing online events like today. We're doing study trips to show best examples that are also outside of our on-farm trials to get more knowledge. We've been to France to visit taken Biofair to see what is new in France, and so interesting things like the MarkTech mulching system. And we're doing some carbon calculation to have more knowledge about this. So organic agriculture is especially suitable for positive CO2 balances because we do not use synthetic fertilizers, and synthetic fertilizers are the thing that the factor that has the most negative balance in agriculture. If you're using normal application of nitrogen, synthetic nitrogen fertilizer, you have a balance of minus 1,000 kilograms of CO2, and that's an amount that you almost cannot compensate. In most cases, you won't be able to compensate this on a conventional farm. With the synthetic fertilizers that are available at the moment that are produced from fossil energy. So some methods are easier to apply for farmers, like cover crops, but also that other methods usually have a higher impact, like agroforestry or cover crops that are a main crop, but they are much more difficult to implement. Yeah, so one of our activities in arable farms is to promote clover and clovergrass because the cultivation period is longer and roots have more time to develop. But you will see that Alois does not use this method, but that means that he will have to intensify his cover crop system, and that's the interesting aspect that we will hear. In long-term Bavarian research results, we can see when we compare conventional to organic farms, they have a number of fields that they compare during the last 30 years, that the main factor that gives higher contents to organic farms, the main positive factors are production of clover and the reduction of intensive crops like maize, sugar beets, and potatoes in organic farms. That are the only really significant factors in this comparison. Yeah, a rotation plan has to include also the cover crops. So if you're growing peas as a main crop, you cannot grow peas as a cover crop. So this is really difficult. So you also need to plan your cover crops. your cover crops have an important role to reduce N losses, but they also can have the role of giving you nitrogen by fixation. So they have different jobs to do, and you can have summer cover crops and winter cover crops that survive the winter under Middle European conditions. We made one of our activities in our project was that we produced a cover crop table that shows most of the important cover crops. This is not new. We got most of the informations that you see here from publications from Germany, France, UK. But our discussion was to have this on one page because the French publication has 51 pages and you need a long time to read it. And here you can see it on one or it's two, in a four pages. The most important cover crops. That's an output from our project. Will be translated also in the other languages, Polish, Slovenian, and Serbian. And of course, we cannot cover all the aspects of the cover crops, but we all at least cover the aspects like juvenile development, biomass production, nitrogen. Nitrogen fixation is quite easy. The legumes do, the others not. High CN ratio, which can be important if you want to fix the nitrogen. We have the criteria whether you can use the cover crop as feed, the winter hardiness, the drought tolerance, late sowing tolerance, and the ability to undersow in the last crop that you do not need to till after your harvest. Then we also added prices from Germany. Of course, that's different everywhere, but at least that you can see which price you can expect when you're growing cover crops. There are cheaper options and more expensive options, and this, of course, usually you do a mix. You need some cheaper components to make it not too expensive, but you want to have some components that are the good ones or the best ones for your location. So we have legumes as a group. We have Poacea. We have some other crops like that's Brassicacea. I think there's something wrong in this table. The first ones are the Brassica, and then the others like sunflower or Niger are some popular crops, and other ones. Also, Facelia is important. Buckwheat is important, and this is on one side. You will also have this. Can get this cover crop table on I think on the Naturland web page, but also on the web pages of the partners. Yeah, so that was it from my side. Lots of projects with KISS. I haven't met Robert, and I'm happy that he's here. But that means, Robert, that you have to present yourself.
I will. We don't have much time to do that, but yes, my name is Robert Leskovšek. I'm a colleague from Alois Ch, which is involved in this UKI project. And I'm a senior research fellow at the Agriculture Institute of Slovenia. So cover crops have been and they still are in the center of our research activities. So in my half an hour presentation, I will mainly talk about how they can contribute to soil health and carbon sequestration, with a focus on the basic principles, but also covering some practical aspects of using cover crops in mainly arable farming systems. So do you see my presentation?
Yes.
Okay, so we can just proceed. So soils are a very important natural resource, and they provide numerous essential ecosystem services that supports all kind of life on on our planet, from humans to animals. So they produce food, feed, fiber, construction materials, regulate water cycles, store carbon, and many other cultural and aesthetic functions. But FAO released an alarming report that was more than a decade ago, that it was written in that report that around 1/3 of the world's soils are already degraded. So if these current practices that we can for sure say that they are unsustainable continue, the most soils could be at risk by 2050. So what do we do? What are the main causes that are influencing that our soils are in bad shape? So one important cause, or maybe the main cause, is are two words, that is simplified and intensive farming. Mosaic landscapes shown on the picture left, on the left up picture, are practically just not seen anymore in the developed countries with intensive agriculture. We can see that only on postcards, or maybe some less favorable areas where traditional farming still exists. So practices like are shown on the picture below. That means an open furrow during the winter time. That means harvesting our crops in very unfavorable wet conditions. These practices, combined with low crop diversity, are causing that we lose soil organic matter, that we deteriorate soil structure, and decrease our soil biological activities. So what exactly are cover crops? The term itself in English is quite explanatory. Crops that cover the soil, and most of the terms in other languages that derive from this are pretty much similar to cover the soil. But of course, there are always exceptions to the rule, and German-speaking languages is one of those. Here we have the term Zwischenfrucht, that means in between, that we are growing some crops in between the main crops. But the main definition of the cover crop is that these crops are generally not intended for harvest. Of course, if we talk about fodder crops, especially grass clovers or their mixtures, they can be harvested, but then in this case is that they are not fully in function to improve soil quality, fertility, prevent soil erosion, nutrient losses, and with development, they do not reduce pests and maintain biodiversity at its full function. So they're usually planted in between main crops after harvest, or during periods when the soil would otherwise remain bare or in the fallow. So cover cropping is not something that agricultural experts or scientists developed recently. Basically, it's an old practice. But in the traditional agricultural system, like Werner mentioned, especially in the organic ones, and basically 70, 80 years ago, all the agricultural system were organic ones. and cover crops were widely used before the broad adoption of synthetic fertilizer, heavy machinery, and pesticides. And cover cropping appeared in many forms. Some of those already were mentioned in the previous presentation that supported soil health and productivity. But mainly in the system without animals, green manuring was used, mainly with brassicas, like Werner mentioned. Those seeds of those are extremely cheap, and it's easy to establish them. And in the more intensive system, catch cropping was prevailing. But in the system with animals, which was pretty much the standard before the intensive agricultural farming came, undersowing, lay farming, and fodder crops were commonly used in these systems, basically because they need to do that, mainly using legumes to introduce nitrogen especially in the arable systems. So why use cover crops if we have other management strategies that can support the list of different ecosystem services that are mentioned here? For instance, like Werner mentioned, we can use solid manure or compost as organic amendment, and it's efficient for both carbon sequestration. It improves soil structure, supports soil life and nutrient cycling. Or, for instance, we can use liming to improve soil structure, or we can use mechanical weed control to suppress weeds. And also there are other measures that can target each individual ecosystem services. But the main advantage of cover crops is that they target all these ecosystem services more or less at once. It depends on the species, it depends on the mixture, but basically we can say that when we have a proper cover crop, properly established with a lot of biomass, we can target all these ecosystem services at the same time. Here we have data from one of the studies from Tiefenbacher et al. There are also other studies that they are presenting efficiency of different strategies in carbon sequestration. And as we can see on the left side, that negative bar is basically bear fallow, and all the other strategies are basically on the zero level, or they contribute to sequestering carbon. But here is the answer why cover crops here are mentioned as catch crops in the orange bar, third from the right to the left. We have other options, other management strategies. They're maybe even better, like using compost. But compared to these strategies, or like reduced tillage, using organic amendments like farmyard manure, which is also efficient, but compared to these strategies, using cover crops, this is these here are cover crops, this bar. Using cover crops is very cost effective, and it's also feasible in many systems. And that's why cover crops are so popular or widely used, not just to sequester carbon, but also to target other ecosystem services. So how do cover crops fit in the rotation? They can fit in various ways, but in this short period of time that we have, I'm just gonna elaborate the most typical case in the central, probably also maybe a bit farther northern Europe's. And cover crops are usually placed in between two main crops, and this is a simple 2-year rotation. We have a time period from October, late fall, when winter cereals are established. and they are on the field until the harvest. That means the early summer, June or July. And then we have in the traditional, in the conventional system without cover crops, we have some kind of mechanical intervention, usually to control weeds. We can do that also chemically if we have a problem with perennial weeds, and then we till this soil and open leave the fields open further during the winter to that this usually in the heavy soil these clods wear down, and we establish the next crop, which is usually maize. But with cover crops in the system, we move from the simple 2-year rotation of cereal and maize, winter cereal and maize. We move from grass monoculture into a more diversified system by using, for instance, clover or buckwheat, the plant species from other botanical families. We can even upscale this diversification by using cover crop mixture. So what are the main functional group of cover crops? In general, plant functional groups or types are plant species that are that have similar traits and play similar ecological roles. So in vegetation science, these are grasses, forbs, shrubs, trees, legumes, annuals, perennials. In cover crops, we usually have these 4 main groups, and the first one are grasses. They usually produce high biomass and produce dense above ground soil cover, and with their fibrous roots, they often improve soil structure, and typical representatives are winter cereals like rye, oats, or species like sorghum, Sudan grass. And then we have legumes with the typical feature of fixing nitrogen from the air, and they produce high quality residues, and with typical representatives of vetch, various species of clover and peas. And then we have brassicas. Their main advantage is that they have a deep taproot, and because of that, they can use nutrients from the deeper soil layer, and with this drilling effects, they also help to relieve compaction. And the last is basically all the other species, usually, of course, broadleaf species, and with typical representatives of buckwheat, Phacelia or Niger. These are more or less flowering species. Depends on the species. They have a different development speed, but they also support biodiversity, or in the case of buckwheat, they also can mobilize nutrients like phosphorus from the soil. Of course, we can mix them. So here we have a kind of a graphical presentation of how the different functional plant types use space and above ground space and access to the below ground resources. They do that in a different way. So by mixing them, we basically are building a dense several layers thick above ground carpet and the complementary root system below the surface. And with that, we are trying to maximize the efficiency of cover crop production of biomass. That is that we are trying to catch as most light as we can, and to have access to all available nutrients in the soil. We can also target or improve specific ecosystem services and aims. For example, we can blend a mix of species that have different flowering times, and with that we support pollinators for a longer period. If we mix different legumes, we improve the ability of our mixture to fix nitrogen. We can also mix winter hardy and non-overwintering cover crop species that kind of prolong soil protection. So basically here sky is the limit what we are trying to achieve with these mixtures. Soil organic carbon is basically a very often term, especially frequently used in soil science, and basically the most important term when we discuss soil fertility, because it plays a central role here. So soil organic carbon improves soil structure. It helps to bind soil particles together into more stable aggregates. It supports soil life by providing energy and food for soil organism. It acts like a storage for nutrients, and by that it retains and releases nutrients mostly to the next plant. Soils with more organic carbon usually hold more water and allow better infiltration, which helps crops during the dry periods. Soil organic carbon also makes soil more resistant to erosion, drought, compaction, and degradation. And it acts also as a storage of carbon by helping to reduce carbon dioxide in the air, in the atmosphere, and putting it into more stabilized form in the soil. Yeah, I mentioned that. So how is this process of carbon storage going? So the first step is, once we sow or establish our cover crops, we basically, cover crops capture carbon from the atmosphere during the photosynthesis and build it into a plant biomass. So this depends on three main factors. That is weather. We need favorable temperatures, some precipitation. We need to choose the right species for our soil conditions, and we need to establish them as soon as possible. So if this all is done, we can hope that we can produce a lot of biomass, and this can be the amounts, the range of the amounts of biomass that we can produce is from 2 to 10 tons of dry matter per hectare within a short period of 3 to 4 months. At least in our climate, those numbers are reachable. The total carbon content in the biomass is 30 to 40%, and this corresponds to about from half a ton to up to 3 tons of carbon, which is temporarily stored in the plant biomass. So roots are extremely important, and this important part of carbon input happens below ground. This area was under investigated in the previous time, but roots release carbon-rich exudates like sugars and amino acids into the soil in the process called rhizodeposition. This represents between 10 and 20% of the total cover crop carbon input. But this amount is important, but it's not the most important factor. The most important thing is that this carbon basically feeds directly the microbes in the soil and also contributes to the formation of soil organic matter. So in contrast to the biomass where carbon is temporarily stored, cover crops roots kind of gives microbes their food directly into the veins, and this is extremely important to support the microbial activity during the cover crop growth. So once we successfully have a biomass, before the next crop, this above ground biomass is usually terminated. So this can happen naturally with frost, or the plants coming to the end of their life cycle, which is very, very rare. We don't want that cover crops is producing seeds which are then weeds in the next growing cycle. So in most cases, we choose the timing when our cover crop is no longer needed, and that is basically when the next planting season is starting. So we stop the growth either mechanically, usually combined with some kind of tillage, but we can also leave that biomass on the ground, as we can see on the left upper picture. And the intensity of tillage is also basically the preference of the farmer. So if this is combined with in the conservation tillage system, then it's usually some shallow incorporation, like some rotary tiller, like in the middle picture, or in the conventional system with plowing, cover crops are incorporated, biomass is incorporated into the deeper soil layers. So this, in the process of biomass decomposition, microbes use this biomass as the source of the energy, and the speed of decomposition depends strongly on the residue quality, or basically on the cover crop that we have on the field. So legumes have a low CN ratio. That means that they have more nitrogen compared to carbon share in their biomass. So microbes are using this nitrogen for their activities, which is good for the next crop, because they release this nitrogen also in the soil. But in terms of the carbon storage, this is not so good, because less carbon is stored on the long run. In contrast, high CN residues in grasses means slower decomposition, which is good on the long run, because we have more stable soil carbon formation. But because of the lack of the available nitrogen for the microbes, they are using available nitrogen from the soil, and then, which is bad for the next crop, because we have a temporary immobilization of nitrogen, and we usually add nitrogen into the system if we want to have a normal development of the next crop. Sorry, I need to drink something. Okay, so we can say that this process of soil carbon storage is a very slow one, and it's also not so efficient, because only 10 to 20% of the total carbon that we put into the soil with this biomass becomes a stable soil carbon, and the majority of carbon is lost through microbial respiration and CO2 mineralization. We also have indirect effects of cover crops on carbon sequestration, which means that we are protecting the existing soil carbon in the soil. So water erosion is a huge issue in areas with high inclination and combined with bare soil and precipitation events. And we also have increasing issues also in the more humid parts of Central Europe because of the drought with the wind erosion. And in both processes, we can lose a huge amount of soils permanently from either agriculture or other areas. So cover crops can step in this situation and reduce both water and wind erosion, and help to preserve the carbon-rich topsoil. where the most of the fine particles and organic matter is concentrated. So by preventing the loss of the topsoil, cover crops help to keep already stored carbon in its place in the fields and other areas. So what kind of level of soil coverage do we need in practice to prevent soil erosion? Basically not that high. So if we see that red line showing what is the soil loss ratio, if we achieve a 50% soil cover, which reduces soil losses by up to 10-fold. So we are basically with 50% soil cover, we are coming very close to basically total prevention of soil loss from wind and water erosion. And usually 50% plant cover is not so hard to reach in our climate, in our experience, in our trials. And with fast growing species, this is usually achieved in a month after sowing. And with soil cover, we are not just physically protecting the soil. Soil covered with vegetation also creates a more stable microclimate, which helps residues to decompose more slowly, and this protection of soil protection is maintained for a longer period of time. So to conclude, some take-home messages. We do need continuous soil cover and to provide or to improve the health of our soils, and we also need living roots in our agricultural systems most of the time, or as most as we can do. And cover crops are a practical, feasible, and solution that offers also other functions which are extremely important on the long run. And the greatest potential lies in well-designed mixture of functional groups. That means cover crop species targeting specific ecosystem services or chasing specific aims. And the core of all the research is basically lies in this investigation of different mixtures. These benefits don't come overnight. We have to repeat the use of cover crops, and we have to fit them in our rotations, and the benefits will come gradually over time. So what about the future farming systems? I don't know what's the case in Central Europe, but in Slovenia, cover crops are almost becoming a standard practice for soil protection and resilience. And what about the future? As some AI sees the future of cover crop, and it looks bright, and I agree with that. The direction will certainly go into firstly collecting a large amount of soil data, environmental data, based on various sensor-based and monitoring techniques, which will support selection of proper cover crop species and mixtures, and that will be tailored to fit specific local conditions. In the future, cover crops will probably be established with drones, robots, or incorporated in other management measures, such as systems where cover crops will be sown together with the harvest. But like I said, in the near future, cover crops will also will have to become a standard practice, because our systems are getting more and more specialized. That means more and more intensive, and in most cases, either we talk about arable systems and other systems like orchard vineyards, where we don't have a permanent vegetation cover. Cover crops will step in and provide this role in this system. This is more or less my concluding slide. I would like to promote my funding project. This is I would like to acknowledge my funding. In this Life for Adapt project, we have established 5 regional demonstration centers, where we're gonna demonstrate agricultural adaptation strategies to climate change, and cover crops are and gonna be the most widely represented practice to support this adaptation. So the project focuses on improving soil cover. It focuses on optimizing cover crops mixture by using more legumes, and we also gonna test and showcase improved establishment methods such as undersowing or drone sowing. And with that, I would like to thank you for your attention, and I'm available for your questions. Thank you very much.
Good. Then we change. We continue with the farmers' presentations. We start with the farm from Poland. Monika and Robert are running a farm in east of Poland. Well, relatively dry conditions, sandy soils, not easy to find solutions for cover crops. So, and I'm happy that Monika will present some of their strategies on their farm.
As I started to say, I'm very thankful for invitation, and actually I will speak on behalf of my husband, Robert Kuryluk, who is an experienced organic farmer from the east of Poland. And as he's not able to speak English nor German, that's why I will speak to you on his behalf. So the next slide, please. So that's my husband. Here is it's the picture that presents you the pumpkin seeds. So it's of course not the cover crops itself, but it also shared the huge piece of field. Okay, and this is the ecological farm in the east of Poland, in the region of Lubelszczyzna. Please, the next one. Next slide, please. And here you can see the map of whole Poland. So we are just very close to the border with Belarus and Ukraine. The next one, please.
It sometimes just takes a second, but
it's okay. We have in the straight way about 15 kilometers to the border, and very close to a very big river Bug. Okay, please, the next one. Okay, and here is a short characteristic of our farm. What is important to mention is that my husband runs it in organic way since 1995. And over 30 years, he tried to use different crops with different variation of fertilizing it. So he has some comparison, and he can obviously see that is very huge change between our farm and the very big farm which is next to us, but run in a very conventional way, which I will mention it later on. And the farm is associated with the Ecoland Association that runs together over many farms through whole Poland. The size of the farm is not so big. It's 34 hectares, and it's run in 15 different plots. So our structure is pretty complicated because we have plots in actually 3 different villages. So it's not in one area, and that also causes that our soil is different. We have mainly sandy soils and not so very heavy. So we have it's pretty high diversity of the soils on the land that we have, and the arable land takes 23.87 hectares. We have then a little bit of permanent grasslands, almost 5 hectares. We have a bit of forests, 3.43 hectares, orchard, a very small orchard, mainly with apples next to the house, and other not used plot. Okay, please, the next one. Like I said, our soils are, well, very light ones, the sandy, loam profile. The classes, I know that in Poland it's a little bit different than in German. We have the classes from 1 to 6, and which means the first class is very heavy and very good soil, and the 6 would be the very, very bad quality. So we have in the middle 3B up to 4, 5, and 6. The average is 4. And average annual rainfall in our region is about 550 millimeters with the continental climate, but we have some feeling that this rainfall is less and less every year. Okay, please, the second one, the next one. And here we wanted to show you the sowing structure for this year, just to give you the overview that we have mainly we are focusing on pumpkins because this is our main plant, but we have of course the other plants like red kidney beans, lentils that we sow together with oats, and the lentils are here as a main crop. Then spelt and lentils with spelt as a main crop. So this is important to underline. Serradella and oats, valeriana, baldrian in German, potatoes, and a little bit of rye with white clover. And actually with this Euki project as the last plot, that's a very small one, but this is also important to mention because we just bought this little plot 2 years ago, and we have this comparison and some experiment does with Werner regarding fertilizing it. Okay, the next slide, please. Okay, here Robert wanted to tell you that when he started to run this farm, and it was before the farm of his grandparents, so it's in our family for over 100 years, but before it was more as a traditional farm with many different kind of animals, so with a lot of manure. And when he started to run it in organics, he stopped to use fertilizers, but he also stopped to keep animals, which is not very good, of course, as organic farming should have animals, but it was too much for him then. And to compensate this loss in manure, he started to put more plants that gathered nitrogen from atmospheric. So he started with lupines, blue, and first years he was very surprised that they were growing very nice on these soils, and they had pretty good yields. But after a few years, it was about 6-7 years, the problem shows up because he started to come back with lupina on the same plots, and then the diseases arose like anthracnosis and fusarium wilt, and he had to stop it. So after that, he started to grow Serradella, and now we do it already over 10 years. And since 3 years, we integrated also to grow lentils And in the meantime, of course, he was still keeping sowing red kidney beans. So depending on the year, he's tried to have the legumes on the average percentage between 20 and 30% of the whole farm, so that it will keep with the legumes. Please, the next one. Here is just an example of picture. I took it 1 week ago, so it's pretty fresh picture. It was just before the rain, because now since few days we have a little bit rain, so the plants are much higher, but the spring was very, very dry. This is spelt and lentils. Okay, the next one, please. I wanted to show you some details from the practical side. So my husband is sowing spelt and lentils, mixing about 270 kilograms of spelt with 25 kilograms of lentils. And he's sowing those two plants on the same day with the same machine. So it's just mixed, and it's from this season. So it was sown on the 6th of October. When we talk about Serradella and oats, when Serradella is the main crop, then he mixes 30 kilograms of Serradella with 30 kilograms of oats. And this year he sowed it on the 30th of March. The next mixture is lentils and oats with 90 kilograms of lentils and 30 kilograms of oats. Then this year we have waited longer, because last year we saw it at the end of March, as I remember, and it was not good thing, because it was very cold spring, and May was very cold. So this year we waited almost 3 weeks more, and he saw it on the 18th of April, and then it looks good. And the last example, rye with white clover. And this is this plot which is being studied this year and last year with rye and white clover. Sowing date the 2nd of October, of course, for rye, and clover was added on the 1st of April. So just to underline once again, if somebody has missed it, when the first plant is written as spelt, then its main crop, and lentils are treated as cover crops. And when Serradella, for example, is on the first place, then Serradella is as the main crop, not the cover crop. Okay, the next slide, please. Like I mentioned, the share of legumes in the overall crop structure for this season is 28.95%, which is pretty high in our standards of Ecoland. We have the minimum. We restrict the minimum share on the 20%, so it's over 10 more. Okay, the next one, please. Here is just a second picture, the next one of the next one. Okay, so what are the observations from cover crops? Like, what give us back such a solutions? Of course, we see it the better nitrogen balance, and when we have plots next, two different plots, with one with additives of lentils and the second one with no lentils inside, we can see obviously from the color of the grain that it's more dark green, so the nitrogen is much better, on a better level. So we can see it not after a few months, but actually from the beginning of growing of the plants. So it must provide organic matter that grains are using just from the beginning. They shade the soil, of course, so minimizing water evaporation. With our situation and the climate and the situation of the farm is very important, because from year to year it's very clearly seen that water is very on a very low level in the spring, especially because we have pretty much rain, but afterwards, like in late June and July, and it's of course too late for the plants to be well grown. So when we cover the soils with the cover crops, the shade is very welcome. It stimulates soil microbiological life. Well, actually, Robert was presenting it in so big details that I probably cannot say you anything more, but these are the points that we clearly see. And in case of spelt and rye, cover crops increases the yield of the main crop. So we see that they don't beat with each other's for the nitrogens, but they somehow compensate each other's and we can see it in the yield afterwards. And of course, we also use it for the seed profit, as we collect the serradella or lentils as a main profit. So from the farmer point of view, it is also important because we have additional economical aspect of sowing those plants. Okay, the next one, please. Just to quickly show you little pictures from the farm so that you have some overview how it looks like and what kind of machines we use. We try, well, as you can see, this is Pronar. So this is the old tractor, which is not very heavy, not very big. And we don't use also very huge and big machines to prepare the soil. And also we can see the difference in the structure of the soil while using that kind of machines. Okay, please, the next one. Here is just the how we fight with weeds, as we don't use any pesticides, of course. So we have many mainly work, but also we use different machines to get rid of the weeds. Okay, the next one, please. Here is the valeriana crop, and this is also the one of the type of keeping it clear without weeds. Okay, the next one. And the second thing, when we use in two plants, actually in red kidney beans and with the pumpkin seeds, we use the gas to burn the coming up weeds. Okay, the next one, please. Well, I will not talk about pumpkins because it's not the topic of the cover crops, but I wanted to mention about them because from our farm, from the farm perspective, is very important, because the cover crops give us the better, of course, soil structure and give us more nitrogen, and this is the great element of the farm when you grow pumpkins, because pumpkins, of course, they also cover the soil very fast with their big leaves, but they really eat a lot of nitrogen. And of course, we give the manure and other fertilizers, organic ones, but we see that with the cover crops year before, the pumpkin seeds are growing much, much better. Okay, the next one. Here is just to show you how it grows. Okay, the next one. Yeah, on the field, we have to take it while harvesting in the big rows. Okay, the next one. They lay down on the field for over a week with the sun to get ready. Okay, the next one, please.
Do you want me to do the next one? This is the
Yes,
one with...
yes, please.
Oh, okay, sorry.
Mhm. Okay,
So this
something has stopped.
sharing the pumpkin seeds, I guess. Do you see that
Yeah,
slide?
we can just scroll it with the next slide.
Oh, Paula, we lost Monika. She somehow lost connection.
Okay, I will look out for
But
her
I
to
think
come
it's
back.
almost gone. This is like the pumpkin seeds.
Mhm.
And so
The
I
oil
think she
out
was
of the
almost
seed.
done, right?
Yeah, I
Yeah.
think
Got
so
it.
too.
So, so you can show us the pictures, and so although
So this
she's
is the pumpkin
lost
oil.
her,
I think that's very good
yeah.
oil.
I also were very surprised. Okay.
Okay, you're back.
Yeah, it's Robert wanted just to show you
Yeah.
and things that we do. And this is the valeriana, which might be also just something surprising for you, because I think that in Germany and in other countries it's not a very common plant. Yeah, we can put the next slide. Where we put it with hands, and in the late autumn, actually. So also before we use the cover crops, especially in mixture. Okay, the next one, next slide, please. Yes, it looks like this when it's coming up. The next one. It's already blue. Yeah. The next, please. Yeah, and here you can see that on our farm, when we dig out the valeriana, the soil is really mixed a lot, and the structure is much damaged, I must say. So this is very important that after harvest we try to put as quick as possible, although it's already autumn, some mixture of cover crops: mustard, serradella, buckwheat, phacelia. Yes, the next one, please. And that's how it looks when we dig it out, when it's fresh. Okay, the next one. And that's the last with the valeriana. Okay, the next one, please. Okay, so I think it's the one slide has been switched off, but I will just wanted to add that after spelt, that's the best example on our farm to describe you that after spelt we saw after crop with especially mustard, serradella, buckwheat, and phacelia. And that's Robert also mentioned in his presentation, that this mixture of different kind of plants give us the best security that if not all, at least half of the plants will grow, because it's difficult to estimate what will be the autumn while harvesting grain in the middle of summer. And Robert starts to mix different crop cover crops with different water needs and different different roots, because that's mixtures give us the best benefits. And that's this mixture stays with us until the springtime. So also there was a question, is it good for the next coming up plants? And from our perspective, from our experience, is very good when they stay until the springtime, because we have winters in the last years with not a lot of snow. And as we all know, the snow, thick layer of the snow during the winter time give us the security of enough water amount for the spring plants to grow up. And when we don't have these cover crops, even if they are already dead, they are frozen and so on, but the thicks that are staring out of the land, they stop the snow. And on the next fields of our neighbors, when we see that it's flat, the snow just with the strong wind, it just goes somewhere else. So this is also an important thing that farmers should think about. Okay, thank you very much on behalf of Robert.
Hello, everyone. Thank you for having me today. I hope everyone can hear me well. Wonderful. You can also see my presentation. All right. My name is Alois Gimplinger. I am from Austria, and together with my wife, I manage an arable farm, which has been an ecological farm since 2020, and this is not, and we do this as a sideline in part-time. We are 480 meters above sea level. Annual precipitation is 880 millimeters, so it's normally humid enough. We lack a bit of warmth. That's the limiting factor where we are. 34 hectares of arable land, relatively heterogeneous soils. We've got everything from loamy sand to silty clay loam. What's also particular is that everything is, all our fields are on hillsides, mostly with a grade of more than 10%, so we're at risk of erosion. Since 2011, we've not had animals anymore. Before we had bulls. Since 2015, we've been working plowless. That was a gradual change from 2011 to 2015. And the main reason to get rid of plows was to control erosion, which we've managed quite well. Not just because of the reduced tillage, but also mainly because we've intensely planted cover crops and applied a diverse crop rotation. We've been ecological since 2020. Of course, we're a Naturland farm, and the goal of soil building to control erosion is something we've managed quite well. We have managed to get our arable fields up to 4% humus, and if you have a soil like that, arable farming is fun. I just want to know, do you see my whole screen? Almost. Wonderful. Just a short overview of the cover crops we used. We started very early on with cover crops, as it was the custom at the time in the 90s, mustard plus oil radish and to the plow furrow in the summer. And then later on, we moved to more diverse mixtures. We added Phacelia and sometimes marigold. This is a picture from 2006. Then later on, 2007, my wife and I took over the farm from my parents. Then we used more high value mixtures, more diverse mixtures that included berseem clover, strawberry clover, Phacelia, mung beans, and the mixtures became more diverse and more high value over time. This is a picture from 2020, one where we included oil flax, summer vetch, soil improvement radish. That's also lots of great plants. And until then, we only worked with cover crops that died in the winter. In 2022, we changed to organic farming, and with that, we wanted to have a lot of cover crops that were high in nitrogen, and we wanted to include because we wanted to supply crops like corn, or cereals with sufficient nitrogen. That's why we've been sowing rapeseed with supporting crops, and we used winter hardy plant covers and two-stage plant covers, and I will address this later in more detail. Two-stage vegetation is one summer cover crop, which is then terminated with a rotary tiller used as surface composting, and then a follow-up cover crop is planted. That's an overview of the different cultivation methods that we use on our farm. This is a short overview to what extent we include cover crops in our crop rotation. So our motto is, whenever possible, we want to have vegetation back on the field. Fallow land is waste, and I don't even want to address the crop rotation, but what I've put in green is the vegetation that we have. And in a 7-year crop rotation, we have 6 green covers, and whenever possible we do that, or maybe a supporting crop with rapeseed, for example, or mixed cultures, for example, triticale with some winter peas. Now I would like to introduce the individual systems in a bit more detail. This is a cover crop before maize. As green manure, we can use triticale, for example. This is a winter kill vegetation with a couple of pictures. We always establish the green immediately after the cereal harvest, and we always manage to establish the cultures well. So in early September, we already have a very nice green cover, and this is a sample of the soil, very crumbly soil at the top 15 centimeters. These are some pictures of the summer veg that we had in the mix. You can see the strong root and the nice bacteria that go that go far down. So the summer veg is really a nitrogen factory with its deep tap roots.
It can be seen on the biomass. What you can hear is also what Robert said in the beginning, is that you see that we are losing carbon. The structure is changing, and you can see the structure now. You see the what we do. Right, you can hear me now. What you can see in our side is what we carry out in our seed to see how the operations are. I see that if you have a good cover crop that is well established, you won't have any weed here. There won't be any establishment of that. And it is sometimes the case that when you look at the stalks there, that you wouldn't see any impacts here, because the seeds that you lose in harvesting will have the germination and will not start the germination process the very day after, because it is developed well the next day and it would cover the soil. You will not see a germination there. Right, moving on, looking at fertilization and the germination process. Sulfur is bare. And what do we do? It is very well established after harvesting. Another system that we have established since the year 2022 is a two-stage vegetation according to the rapeseed before we do maize. Now, why do we do that after rapeseed? We see that we can get rid of the rapeseeds there and have a two-stage system that is being used, which means that it overall shows that there's a great saturation of the summer crops. That is the reason for having the two-stage vegetation. What we also noticed is when we looked at the vegetation, as we show the soil structure here, October, November is the great starting point here. But over winter, it is quite cold, closed off overall, the greening, and then you see a decline overall in the soil structure. January, February, March, it's no longer nourished, the soil as such, because there are no young roots inside. But when you have a two-stage vegetation after summer and you have a winter hardy crop in there, you have very young roots, you will have an optimized stage and can get rid of that problem. It's greatly nourished. With the rapeseed. That's the only exception that we have here. We want to see the germination here. So we will not do that straightly after the sowing process. We will wait at that process and have a system in place for the mulch. Use a system of 2 to 3 centimeters for reducing that water evaporation here. It is being removed then, and then after 2 to 3 centimeters, you have a very diverse, biodiverse cover crops. We are using different types that like moisture, and it's not, as it was mentioned, where there's a lot of drought and dry situation in Poland, for example. Here, the Ciradella likes warm weathers. It's subordinate to us. They like it warm. We showed that mungono beans, for example, or linseed is shown here, safflower as examples. And if a colleague has oat on our side, we will have the mixture with oat or buckwheat. That is always possible. Looking at the fertilization, that is possible in the existing system. Now looking at how it can look like, the two-stage vegetation after rapeseed before maize, on the left-hand side, you see a lot of rapeseed is still there. That's no issue at all. On the right-hand side, you see the test we conduct with a spade, and you see the roots beautifully going downwards. And it is a wonderful structure that shows us the soil structure. It's very fluffy. Now, when we look at the conditions in September, This temperature is always great, active soil that we have. It's all about the moisture there. It shouldn't be too dry and it shouldn't be too moist. And when we look at the moisture and it's fine, we will then start you see the structure here, front mulcher on the left-hand side, and the milling machine in action on the right-hand side. You see the above soil material is being shredded, and the machine uses the top 4 to 5 centimeters in the grinder that will then mix it beautifully, the mulch with the organic substance and the soil, which means we have a fine grade organic material which can be used and have a great overall material, soil bacteria and fungi, and have that desired humus. In September, we do so greatly that after a week or 10 days, you won't be able to see anything of the green organic material. This is great to see from an organic material point of view. It is primarily for humus. What we then look at is the hardy vegetation. At the beginning, we are looking at the emmer that was then used much more than the winter wedge that was used. It is used in that particular way to create that particular superficial mass, because what you can see, it develops strongly at the beginning and it can be quite challenging. To bring that into a system and implement it. Therefore, we are ready to look at using that in our system that have great roots, as you can see on the right-hand side.
But they have less mass development above ground in the spring because we don't want to have negative yield effects in the following crop, like Robert said it in his presentation. And that's what is a bit of a challenge about the winter hardy cover crop, and that's why we switched to slower growing species. On the right-hand picture, you can also see very nicely how long and intense those roots have grown, even though above ground you can't see much of the plant yet. The root appendage is also great. So we've got a nice hotspot of soil life around the root. So this is a real booster for soil life, which is what our goal was with this. And this is what it can look like. This is what it can look like in spring. That's a picture of the 3rd of March, with nice crumbly soil. We dug up a sample, and with the winter hardy greenery, we usually terminate that with a combination of front mulcher, rear tiller, rotary tiller. It's important that the soil is still a bit wet. If it's too dry like this year, I don't use the rotary tiller because otherwise the soil aggregates will be destroyed. So if we have dust after the rotary tiller and we don't use it, then I use a cultivator. This has nothing to do with cover crops, but this was the maize after this two-step vegetation cover that we then sowed in 2024, which developed very nicely. We can say that you can see very nicely that it had never had any lack of nitrogen. It was very well fed, and only 7 to 8 cubic meters of poultry manure was used. We have a cooperation with a Naturland poultry farm. They get some fodder from us and we get some manure from them. It would have needed some more, and from the manure we had only 50 to 60 kilograms of nitrogen, and the rest of the nitrogen came from the green manure or some from the previous crop, rapeseed. But what I want to show you with this is that with well-developed cover crops, it's possible to generate quite a lot of nitrogen in your system, which will then benefit the following crop. Another system is what we call a quick summer catch crop. For example, if we want winter peas after triticale and maize in the summer, we have a maximum of 7-8 weeks, and we establish a catch crop in between because we don't want to leave the soil bare in the summer. And we use quick growing components such as buckwheat, Niger, oats. It can be a bit of a cheaper mix as well. Otherwise, our philosophy is high value mixtures, which obviously drive the price up a little. Such a quick summer catch crop is also terminated with the rotary tiller, and then a week or 10 days later, the following crop, which is winter flax here, is sown. Another type of vegetation cover is winter hardy cover crop. So after maize before soy, after maize before faba bean, and again we use more slow growing grasses and cereals, camelina, ryegrass, ribwort, also we undersow it as well. We've heard that some don't keep the winter hardy cultures. But the few days where we have below 10 degrees down are not enough to kill the camelina. We can see the maize stubble here. It can be a bit uneven, can look a bit rough. That's no bother, because it is then also turned with the rotary tiller or the cultivator. In the spring, we need a bit longer, for about 4 weeks, until the compost is through, and then we can start with the next crop. Alois, you should get to the end now. Yes, we're almost done. Thank you for letting me know. Then rapeseed with a supporting crop is also a kind of cover crop for me. We are very successful in establishing rapeseed with a supporting crop, and that has the same effect for me than as a cover crop. In the picture, you can see 1 week or 10 days after sowing. Between that, we had 225 liters of rain and had no erosion. You can see that the soil is still a bit crusty. And then later, the picture in October, in the spring, the supporting crops died, only the rapeseed remained, and it became a pure rapeseed field. That works very well as well. And that brings me to my conclusion. So the philosophy of our farm to use vegetation covers is use cover crops whenever possible. Every week is used to establish cover crops. And we also sow as early as possible, if possible, on the day after harvest. We always use diverse, high-value mixtures that have a certain price, of course, but we have had the experience that it's definitely worth it because it generates a lot of nitrogen. Because we are a farm without animals, you get a lot of nitrogen and a lot of carbon into the system, and humus is built and the soil is developed. And our goal is, as Werner said at the very beginning, I don't know if you noticed, as an organic arable farm, we do not use clover grass or lucerne, and as a replacement for that, in quotation mark, we use intense cover crops to develop the soil and promote active soil life and stable soil structures. So up to now, that has worked very well, and I can only invite all of you to plant cover crops as often as possible, as intensely as possible, because it is a great tool for increasing your crop rotation, introducing nitrogen and carbon into your soils, and to make your soil more alive, more resilient. And that's the end of my presentation.